thing about the list of data, which is variable length argument list. So what is this? Um, when we are defining a function or so, in some cases you'll see that 3 dots on this, which means like int and then 3 dots. It means that this function might take a varying number of values. Like when you see, like, because when we define a function, we say that, okay, it takes 2 integer values or it takes 3 integer values. But if I say that, if you see that in this way, for instance, double and then 3 dots and then the variable name, it means that it can take 1, 2, 3, 4, any number of double values. Okay? So then, okay, then what does it mean? Well, actually, it means, then how can I know that? How will I proceed it in my function? Like, because is it 1, is it 2, is it 3? Well, basically, you will treat it as an array. So in this example, for instance, now you have numbers, and let's say that you want to calculate the average score of a given any number. And then, well, what you can do is, well, we first initialize the total with 0, and then we iterate over all the numbers in that list, which is numbers here. This is our parameter, as you can see. And then at each iteration, I update my total score. And then when I will return by total, which is the sum divided by the number of items in that. Check that we say that length because we treat it as an array. So you might see this kind of a notation also. And why is it useful? Like, why didn't I put an array instead of, like, I could also put array and then it would calculate the average scores in that given array. Like, if I'm treating it as an array, why didn't I put square brackets and mention it as an array? Well, the reason is that it gives you some advantage in when you are using this function. Like, I can say 462. I could put just throw some numbers. Let's do an example for this. So going back to our code, let's write it here. Let me actually do this. I would like to copy paste of this. Yeah, the indentation is terrible right now. Let me quickly fix that. All right. So this is one way to do it. Or we could also do it in this way. Like, the content didn't change at all. I don't need to. But the thing is, it will change the way how I will use it. So I would like to throw this away. And then I'm going back to this part. I will, just copy paste this. So when it is an array, if I define it like this, now I'm not able to use it like this because it says, okay, just put 3 doubles. If I would like to do it now, what I should do is I need to create a double array first. Name double, like 3 items. And then A is 0 is 4, A 1 is 6, then A 2 is 2, then I could only say, then I could put A here. Okay, so this is one way, or I could, with the curly brackets, I could do it. But now, if I do it in this way with these square brackets, with these 3 dots, sorry, well, what will happen is I would be able to just say, okay, give me the average of 1, 2, 3, 4, and I don't know, 8, for instance. Or I can say, okay, I just want to calculate the average of 2 numbers. Or I want to calculate the average of, I don't know, even much more numbers. So it just brings some easy usage for that. Okay. All right. Shall we proceed?
We are considering the 3 dots as an array, so we can use all the array methods.
Yes. So when we have it, like, you can also even write, if you would like, of course, numbers 0 or so. So you really treat it as an array, but of course you need to know its length and so, but yeah, we even access it with those square brackets. All right, do you have any questions so far? Now we will start a very important topic actually. Like, okay, it's not covered in the midterm, but the topic itself is pretty important, okay? Which is the exceptions. And I have 20 minutes, okay, good. So what is this? An exception. When we are writing a code, what is our main motivation is this. It's easy to write a code when everything runs smoothly. Like let's say that I implemented a web application. I'm asking users to say, okay, what is your birth year? Okay, what is your age? And then I'll just get that input from the user and then convert it to integer and then use it in some place. I am assuming that the user will provide me digits. Like, what is your age? I'm expecting 40, but then he writes FORTY. Then I'm trying to convert that FORTY letters to integer, and then my program will crash, basically. Or, well, I'm saying that, okay, give me some numbers, then I will take the average of them, okay? Then the user, well, maybe intentionally or non-intentionally, does not provide any number. So I have 0 numbers. Then I divide it by 0. And then my program again crashed because I'm trying to do something mathematically undefined. Like, what is the divide by 0? So that's also another problem. Or maybe, well, I have a server, or maybe I'm running a very large data. Like, I have 3 million of data points, and I want to process them, rank them, or so, whatever it is. And it's very likely that the program will run maybe days, hours, or days. Like, think about these large language models. So they say that they use thousands of GPUs, and then they run it for days or weeks or months so that they get this model. But for these kind of long executions, if you don't take any any action, you are just hoping that, okay, inshallah, there will be no electricity power problem. Because if my computer loses the power, my execution will will fail, and I need to restart it again. And then I need to say, okay, inshallah, this time there will be another no more electricity power, so this time I will be able to finish it. But probably, like, it's very likely that it might be disconnected. So again, I'm just hoping, so if everything goes smoothly, okay, it can finish. But what if it doesn't? Like, let's say that you are writing an application, right, that gets data from internet. And then so the process is like, you get the data, you process it, and maybe you will present the data, and then you get the other data. So it will run 24 hours in a day and for 7 days in a week. Then, what if, I mean, your code is fine. There's no problem with that. Your computer has no problem, but the server is off. So they have some problems. Maybe there's something happened, and then what will happen is you are expecting a data from that web page, but they are not responding. So then probably you will not get any data, and then your program will crash again. Or, well, you are reading a data from a file, okay, and then you want to process it. But then your little brother came and then deleted that file while your program is running, okay? So in the beginning it was there, but not anymore. So your program is assuming that the data is there, but it is not. Then what will happen? You are not able to get the data that you are assuming to have. Then your program will fail again. So in short executions, you might be say, okay, I'll just run it again. That's fine. But in a professional product, a software product, you cannot assume that. Like, you cannot sell a product says that, okay, this runs very well if everything goes smooth. Okay, what if it doesn't? So in a professional product, we should think about all these cases, like, because it's not anymore like a course project that, okay, it will just run for 5 seconds and there's nothing more, but it will run all the time and you will not be able to provide maintenance immediately. It's a product. People paid money to buy that software, and maybe you made some $1 million contract with the government, and then in the middle of night they said, okay, it's not working. So this is not something that people will accept. So for that cases, what we want to have plan Bs. Like plan A is like our normal execution, but we need some plan Bs, like what should we do if the website is not available, if the program is, I don't know, the data is not there, if the user enters some invalid characters, what if we are trying to divide by 0, what if the value that we are assuming is actually null. So we need some plan Bs. If it is not null, I will do this, but if it is null, I need to do something. Like if the object is not there, the server is off, it's not available, well, plan B, wait for 5 seconds. Maybe it will be on. Then you can just try again. And then maybe, of course, you can have your plan C's, plan D's, whatever it is, but at least your program will not immediately fail. You'll say, okay, maybe your next plan is, okay, we waited already 5 seconds, it's not available, then let's, I don't know, do something else. You can, maybe you can skip that part and so on and so, but at least your program will not crash. So we want to have programs that will be able to run whatever happens. So it will be able to handle the problems. This is what we want to have in our cases. So we want to develop cases for plan Bs. And this is called the exception. So exception is basically, it's a problem that happens during the execution. And then what we want to do is, we want to handle that problem. And here we say that, like, when a problem occurs, like this is also like an invalid index array. Like your array has 10 items, but you are trying to reach the 11th one, or you are trying to reach the -1 index. So this is also a problem. Like it will kill your program immediately. So what will happen is that then the Java virtual machine throws an exception. I'm emphasizing on this because we will use this throw as a keyword later on. It throws an exception. So our program is going on, and then it throws an exception, which is, and then it will, if we cannot catch it, I'm again emphasizing this word catch because it's also a keyword in Java. If we cannot catch it, the program will crash. But if we can catch it, which means that we can execute our plan B. So let me check if I have is to say here. So yeah, our main goal is that we want to have fault-tolerant programs. What it means is it has a tolerance to the faults. Whenever there is a failure, it will be still able to go. It will be able to tolerate that failure. So how do we do it? We will use this try and catch statement. So what is this? Try is, well, basically what we are saying is that, to the Java is that, okay, in a try block, we are saying that, okay, try this code block, okay? But it means that, like, you might not be able to achieve it. Maybe it might fail. This is like a minefield. It's risky. It might not run correctly as we expect. So just try it. You might, the JVM can throw an exception in this part, and then, but I will provide a catch block. But no worries, I know how to catch it. I know how to handle it. So, like, what can it be is, like, I'm trying to get that data from a web server. I don't know, maybe it's not available, so I will put in a try block. Then I'll say, okay, try to get the data from that web server. If we can achieve, that's good, then we can proceed. If we cannot, plan B will be executed. So this is what we are trying to do. And here is one example. So, oops. So try is our keyword. And then between curly brackets, we write our risky code, which means GVM can throw an exception. Or in other words, there can be some problem with this code. Okay, so this is what we are saying to Java. So try to run it. Maybe you achieve, maybe you not. We don't know, but just do it. And then what we'll write is our code is here, our risky code, and then we write this catch part. So this catch is our plan B part. So basically what we are trying to do here is, now we define an array, and then we print it, but with the index 3. But do we have it? Like we have 3 items, the largest index is 2, so we are trying to access an item that doesn't exist. So then Java will throw an exception, and it is array index out of bound exception. So what will happen is it will not crash your application, but also it will not run the remaining statements also. So it's not like, okay, I didn't crash it, but it will still continue to run it. No, this is not the case. It will not execute our plan A, sorry. Plan A is to print this number and then to print the number of array size. But now there's a problem, so we are now going into an emergency case situation. It's not working, so we catch it. How do we catch it? Well, this is like a baseball game. Okay, so it throws an exception, but then this catch block is only able to catch a particular type of exception. So there might be different types of errors, like trying to access an index that doesn't exist, trying to read a file that doesn't exist, trying to divide by 0. So there are different problems. So for each problem, we might define a different plan Bs, different solutions. So this is our solution. Whenever there is a problem with trying to read a data that doesn't exist in an array, so this only catches that. And then what we will do is, well, we will just print a message. That's fine. This is our plan B. Not maybe solving it, that's fine, but at least we are letting them know that you are trying to do it. But what will happen is, okay, this part will not be executed, but this will be executed. But the good thing is, our program will continue to run following the and it will not be crashed.
So do we have to memorize every kind of exception?
That's a perfect question. In the following lectures, we will see checked and unchecked conditions, unchecked and unchecked exceptions. There is a term like this. And what is this? Very briefly, whenever you access an array, should I really write this? Well, it will kill the readability of our code because we reach many times arrays, so it will make our job very hard. So Java basically says that you don't have to. Java is not forcing you to write them in between try and catch blocks. The reason is that it will reduce the readability, and also there is another problem. Like if you are trying to access an item in an array that is not in, like you assume that you have 4 items, but actually it is 3. So you are trying to get the index 3, which means that there is actually a bigger problem. You shouldn't run plan B here. Probably in your code there is an algorithmic problem. That's why you are trying to reach an index that is not available. So in those cases, let your program crash. This is what Java is saying actually. You need to really fix that. Don't do plan B, go and fix it. That's why Java is not forcing you to put it in a try catch blocks. But are we able to do it? Yes, we can, but it is not forcing it. But in the following lectures, we will see that in some cases, Java is forcing you to write it in a try catch block. Like, I want to read a file. Then Java will say, okay, good, but you have to write in a try catch block. It's not allowed to take that risk. So you have to put in a try catch block. You should define your plan B definitely. This is what Java is saying. But for these array options, array access, it is optional, and you don't. It's not forcing you to write it, because of the reason that I said. It will reduce the readability, and if you are having this problem, there are some bigger problems that you really need to solve in that in your program. All right, and also there might be some other things like, again, we defined an integer array. It's null. We didn't initialize it yet, but then we are trying to reach its length. So again, that object does not exist. If we attempt to do it, the program will crash. So what? And it will basically throw this null pointer exception. It means that you are trying to use a null object. So we will be able to catch it here for those problems. And the other one is, again, in our code, if we try to attempt this kind of line, like we have 3 items only, but we are trying to reach, 10, our program will crash. Again, what we can do is we can write the net try catch block. Here you see a different code, which says exception, not array out of bound exception. This will make more sense when we see the inheritance, but basically it means that exception means like whatever problem type is, I will always do this. Like exception means that any exception type, it will be called here. Not only array out of bound exceptions, but every type of exception will be handled here. And also, I have 2 minutes. Okay. This will be like an introduction for the finally part. There's one more code block, which is the finally block. Finally block is basically the things that you really have to do before you, even though you execute your plan B. Like, there is a fire in your home. Your plan B is evacuate the building. But even though at that case, you should take your kids first. Okay, this is your must. So you cannot just evacuate and leave the kids at home. You should also take them. So finally is the code that you should definitely run whatever happens. Even though, so we put those codes here. Like I'm trying to, and data item that doesn't exist, okay, I will not run the rest of my plan A. I will run plan B, and I will run whatever I really have to run it. I will run it either in plan A or plan B. This is the part that we put in the final block. I will stop here, and we will continue this